Hello everyone, welcome to Magnetism, torque experienced by a rectangular coil in magnetic field. Now, let's say we have a rectangular coil PQRS at an instant like this and magnetic field of lines going like this. Now, there are four arms, namely PQ, QR, RS and SP, and they have their each forces acting upon it due to the magnetic field and the current. Now, for the first force F1, this is equals to BIL sine theta. But here the angle between magnetic field and current is 90, so sine 90 is just 1. So this is equals to BIL. Now here for the force F1, its direction is given by the Fleming's left hand rule. Now I forgot to mention in the previous video, but the direction of the Lorentz force is given by, well, I is the scalar, so it's B cross L. So it's perpendicular to the plane containing magnetic field and length. So that is the reason right here, perpendicular to plane of B and L. And if you want the direction, well, here magnetic field goes like this and current goes down like here. So the Lorentz force goes out like this, but in the case of electrons, because we're talking about current, so there's electrons, the direction is reversed, so it actually goes inward over there. So this is actually going inward and not to the sideways like this. Now for F2, well, it is again BI. Well, here the length is actually the breadth of the rectangular coil, so it's B, and it is also sine theta. And here it is making an angle theta, so it remains as this. And again from Fleming's left hand rule, we have magnetic field and current, direction of current going like this. So Lorentz force should be going up like this, but in the case of electron it goes down. So its direction is down. Now for force F3, well, it is similar to F1 or exactly as F1. It is also BIL sine theta, but here it is 90 degrees, so it's also BIL. And here is the same reasoning, or the direction is given as perpendicular to plane of B and L. I'll just write perpendicular to plane. And for F4, it is, well, again it is BI into the breadth sine theta. And here again, using Fleming's left hand rule, current like this, here, its direction is up. Now we have force F2 and F4. They are equal in magnitude, but their direction, or their opposite in direction, acting in the same line of action, which is this vertical line. So hence these forces cancel each other. That means there is only a horizontal force acting upon it, because here F1 and F3, they have, well, same magnitude and opposite in direction. However, they act on different lines of action, and they are separated by a distance of breadth, which is the PS. And here now we can find the torque of this rectangular coil. Now the formula of torque is, well, force into their perpendicular radius. Now here for the force, we can choose either F1 or F3, which doesn't matter because they're equal, and the perpendicular distances between those two forces, which here is B cos theta, because if this is B, and forgot to mention this is angle theta, so this is the cos component, so it is B cos theta. So let's choose F1, I'll write in bracket, or F3, multiplied by B cos theta, which will be from earlier BIL into B cos theta. Therefore the torque experienced will be BI A cos theta, where A is the area of the rectangular coil. Now, if this rectangular coil has n number of turns in it, so it's n number of turns, then the torque will be n by a cos theta. This is the required expression for the torque experienced by rectangular coil in magnetic field. If you learned something new, please like and subscribe. Thank you.